This is our Tinkercad circuit. In this we are using two ultrasonic distance sensors, two force sensors for checking the stability of the walker, and two servos for taking appropriate output action based on the inputs. Now our concept is that we check if there is any obstacle in front of the walker, or if the force difference between the two force sensors is greater than a threshold value which has been set to 4 newtons in this simulation, then we say that the walker stability is improper, and we take appropriate action by rotating the servos by a certain angle. For this demonstration, the angle chosen is 60 degrees. So now let's see the simulation. So as you can see, currently everything is fine. So the red LED glows. Now if I see the force sensor values, they are currently set at 0. So if I increase one of the values up to 4 newtons, so before 4 newtons everything is alright. If I increase them to 4 newtons, a bit greater than 4 newtons, then the difference is greater than the threshold, and the second LED glows, which is the force sensor alert LED. We have used 3 different LEDs just for the clarity of which kind of error has occurred. Now if I pull it back less than the 4 Newton mark, then everything is fine. Now for the ultrasonic distance sensors, currently they are in a range of 185 to 215 centimeters, as the ideal safe distance has been set to 200 centimeters, and the variation that is possible is plus minus 15 centimeters. So if I just move it beyond to 15 centimeters, you can see that the servos again start rotating and the second LED glows. We can also have two types of problems at the same time, and the two LEDs glow simultaneously. So this was the simulation. Now we will take a look at the code. So this is our code. We have first declared several variables. First two for the distance, then this is the counter variable, this is a safe distance parameter variable, this is for the original model that we are going to use practically. So we have set that distance safety to 150 centimeters. We have also declared two servo variables. This function enables us to use the ultrasonic distance sensors and get appropriate inputs. Here we are setting up all the pin modes, like if they are output pins or input pins. Then in the void loop section, we are first calculating the distances from the distance sensor inputs. Then we are checking the distance safety parameters, if it is safe or not, and then if it is not safe, we are taking appropriate action. This block of code here is for the flickering effect of the red LED, and if otherwise, if everything is fine, then we just set the green LED to glow, red LEDs are turned off, and the servos are at certain fixed angles where braking does not take place. These angles have been came across by physical testing, and this was the Arduino code. And as you can see that it has properly compiled, so the code is also fine.
So this is our final plan model, and so here we can see that there is a space kept for the indicators, and there are the comfy handles and two rotating surfaces. So over here there is an angle where we can set our ultrasonic sensor, and from the front view we can see that this is our wheel, and it is on the surface absolutely aligned with the back gliding. And from other views we can see that there is our locking systems. In the back also there is locking systems here. Yeah, fine. So it is a bit different from the general model that we can get in our available markets. There are many less rods still it is perfectly placed, so that there are no problems in the mechanics, so that it is well sturdy and it is capable of bearing the load of the boulder.